Okay. Hi, everybody. Thanks for coming this afternoon. So I'm Rose Beiler, Associate Professor in the History Department. And we're here today to talk about a leaflet as a tool for doing spatial visualizations. And with me is Evan Wallace, who is a PhD student in the Text and Technology program, and Casey Carnes, who has been working as a research assistant on my project. So we're here today to talk about Leaflet, but we're using Leaflet for a project called Print. Print is people, religion, information networks, and travel, the dynamics of migration. And so Print started out as a book project that I was working on, and the book project's communication networks and the dynamics of migration from 1630 to 1730. And in this project, I was looking at, and am still looking at, the communication networks of religious minorities, religious dissenters in the 17th century, in particular Quakers, Mennonites, and Pietists, all of whom did not belong to official established churches, and all of whom in the 17th century were fairly radical. And what I am looking at is the ways in which their letters created and helped me to understand why these networks evolved in the 17th century, and then the ways in which they shaped migration flows, in particular to the British colonies, but also within Europe in the early 18th century. And so, in the case of the Mennonites, who actually, and I use Mennonites to talk about Anabaptists from a variety of places, and they really weren't a singular religious group. They were many different groups. But the Mennonites in the Netherlands began to assist Swiss Mennonites who were being banished from Bern. And in the process of communicating with them to help them, first of all, try to be able to stay at home, and then eventually when they were not able to stay at home, they were sending them letters to help them with money, with household tools, and just to find resettlement opportunities. They began through that process to establish sort of ongoing connections and find shared beliefs and create sort of a common identity. The Quakers, who themselves were oftentimes imprisoned and persecuted in the 17th century, began to send missionaries from England and Scotland into the Rhine River Valley, and they targeted communities that they thought were sort of like-minded, that they thought would be easy to convert to Quaker ideas about the truth. And so in the process, they went to Mennonite and Pietist communities where they began to correspond then with Mennonites and Pietists. And so what I'm really interested in is the ways in which these networks that started out being about religious persecution and also about missionary work began to overlap and intersect and began to become channels for information about resettlement. And in that process, I argue that they helped to shape migration flows to the British colonies. They helped to encourage German-speaking immigrants to go to the British colonies in the 18th century. So I started this digital project, Print, really evolved because I was having trouble showing the fluidity and the constant sort of kaleidoscopic networks in a two-dimensional form. I kept trying to show them on a page and couldn't find any way to map them. And so Print is the digital project that grew out of that, and we're looking at using visualizations in order to be able to show that fluidity, right? And so we're using Leaflet in particular to solve a couple of digital problems. I'm sorry. To solve some digital problems and to sort of address some challenges. So the first one is just simply to show how the networks evolved over time, right? And also across space. So they really change in terms of their geographical, the connections change geographically, but they also change culturally. And we wanted to show that space and how that shape and how that evolves. The second is that we wanted to be able to visualize mobility and movement. So the people in these networks are constantly moving. They're never staying still. They're either traveling as exiles or they're traveling as missionaries. And so again, the sort of shape of those networks are changing and the people are moving. And then finally, we also wanted to think about how we could show supporting evidence to demonstrate the connections between the people. And to show how those participants in the networks were connected in some cases because of religion, but not always just for religious reasons. There were also social and cultural reasons that they were connected. And these were networks that crossed a lot of political, cultural, linguistic boundaries, and as well as religious boundaries, right? So we were interested in showing the complexity of those connections, and therefore we wanted to show the evidence, which is the correspondence. And so I'm going to turn it over to Evan and to Casey to talk about the tool itself.
Abby. So the platform that we're using, as Dr. Beiler mentioned, is Leaflet. Leaflet is a free and open source platform, which when you look at the economy of other GIS software is kind of a peculiarity. We here at UCF have access to some GIS mapping software, such as ArcGIS. If you weren't inside of our institution, you'd be looking at paying anywhere from $800 to $3,000 a year to use that software. So Leaflet is a JavaScript library that is built on top of OpenStreetMap, which is a project that is maintained and with the full purpose of having a GIS and raster coordinate system that can be loaded in a web framework. To be completely free. The platform is built in JavaScript, which is a very common language used in web development. It's part of the main web stack, and it's maintained on GitHub. Contributors can make packages and other contributions to the platform. And what that means for us, since other academic institutions have already kind of embraced this platform and fleshed out some of their projects with it, is often if we're having something that we need the platform to do that it doesn't do when it ships out of the box, often there's a plugin that enables us to do that quite easily. Another reason that we like the platform is because we're looking at attracting community curators and transcribers, and if they were to need to interact with our platform, something with a paywall is kind of putting up a roadblock to that. Also, since we are looking for grant funding, and these contracts for these other GIS softwares are often on a yearly software seat, not just buy it once and have it for life, it's very hard to project how many funds, and it generally puts a shelf life on the project, which can mess things up when you're looking at your retention policies for your data management plan and these type of documents that are required by grant organizations these days for these digital humanities leaning projects. So we have two reasons that we really like print for this project. The first is you can use it as a timeline to display a narrative. A lot of what we're trying to do here is put these letters in a specific place within a specific context. It's kind of a historical place and space theory. With our sources, the need to show place over time is rather crucial. And an example of a project that has used this timeline function quite nicely is the Jamaican slave revolt, which happened in the 1760s. Do you remember what institution put this project out?
It's Vince Brown, and he's at Harvard, so I assume that's where it's...
Right, I believe that's what I'd seen. So if I click play up here, they have a historical map. You can use historical maps in Leaflet. You have to use a plugin that was developed. We have successfully done it. Casey is currently making his way through it. But what it's doing is it's tweening you through the timeline of events. If you clicked on those bubbles, they give you information. They populate with pictures, links, text, any type of media that can be loaded into an iframe, basically any type of website content. So down here you have the timeline, which you can click through. There are more features that he's not using, but we'll show that in the next slide. But as you tween through, the zoom level is going to change on the map because some of the paths that are happening during the dates are changing. So this was the first example we found of a historical map that was using some of these more advanced Leaflet features. And this is the Jamaican slave revolt project. Let me get out of here and go to our next slide. So another thing that we've kind of dealt with down here is, this is a screenshot of ArcGIS or
No, that's
Google
a
Maps?
screenshot of Gephi overlaid onto Google Maps.
Right. So these are they're all the letter trails. When you're sitting here zoomed out so that you can see the British Isles and kind of the tip of Western Europe, there's really, can't make much context from this. There's just too many lines going anywhere. The lines are demonstrating connections, but as you'll see with this next project, which is the slave voyages on the Transatlantic Slave Database, you can change how information is displayed at the zoom level, which means that if you need to zoom into a town or something where a lot of correspondence was coming in or out to and look at a single actor on the field, you can click on their individual node or point. Whenever I say node, I'm referring to a point where correspondence meets. Let's see here. This is a much more fleshed out example of the timeline tool. Let's see if it's going to populate. So these are all of the slave ships, and I'm going to tween the timeline up to where there's some more activity. All of these dots are following polylines, and they're mapped in GIS coordinates. This looks very nice. If you can hash out which country is which dot, you may get some information at this level, but I really kind of think of this zoom level as like an ooh and ah type zoom level because you're not getting much information. But if you zoom into the map, we're going to pause. If you zoom into the map and click play, let me change the timeline speed down. 0.5. You can see a much more like coherent demonstration on where these ships are going. And if you pause the timeline at this zoom layer, you can actually click on each path and see what the ship was and where it was going, because this is a complete collection, I believe, of all of the slave ships coming out from Portugal, Great Britain, including the Royal Africa Company, Spain, France, Uruguay, Netherlands, USA, Denmark, Baltic, everywhere. So I believe this is a collaborative project that's been going on for several years and has received significant funding. Back over to here. Casey's going to talk about zoom layers and rendering.
Cool. Hi, I'm Casey Carnes. So I've just been working on the front-end development of this, and basically the same thing Evan was saying, where if you're zoomed way out from that previous slide, you're not really getting any information from that, unless you're like Dr. Beiler and you've studied the documents and you know, okay, all of these lines are really telling me that communication was flowing along the Rhine. You're not learning anything, but thanks to the way Leaflet works, you can drill down is what it's called. You can zoom down to a higher quality zoom layer and see each individual interaction, click on it like he did, and then that all links into a larger website. So because of zoom layers, you can really give someone who's a layman on the subject, someone who really doesn't have any intimacy with the documents, and let them understand what's happening, because they can go and click on each one and have it basically explained to them. So just to give you some background, basically web maps were not practical before this tile system. I think MapQuest was the only one that used an online map without a tiled system, and it would take 30 minutes to render. You can't zoom in. It was only America. But because of this system, it's only going to load all of the tiles that are on your screen at one time. And every tile is exactly 256 pixels, so that's a very small image resolution. So you can pretty much get as high a resolution image or map as you want. Some of these maps have 18 zoom layers, and this little example shows how it's increasing exponentially. I mean, by the time you get to the 18th zoom layer, you're able to zoom in, to the city block on New York instead of the whole world or the whole planet. So it really does give you the flexibility to look at that macro and micro perspective, and that's a really advantageous feature of Leaflet, specifically because those features, those little ships or our letters, they scale down. They always remain in the same location. When the map changes, they're still at the same longitude and latitude. So none of that's going to change. You have one map that's constantly in flux, kind of. It's all bound to the same coordinate system. It's all geographically correct. We'll go right into this. Okay, so this is how Leaflet works, and it is a little incomprehensible, but this is actually one of the reasons it's so flexible, so accessible. We talked about the different plugins. What we used to make our tiles was this Digital Tiles program, and I think that was developed by MIT. So basically, at this step, the raster tile step, you can choose whichever software, whichever system you want to use, any of the Mapnik, Carto, MapTiler, anything you can find online. It says, if you give us an image, we'll chop it up into these tiles, these zoom layers, and you can display it not only on Leaflet, but realistically on any web map library that you want. We're only going to use Leaflet. I think Open Layers is the other example. But all the way from the very beginning, I mean, we have the computer science department, I think, working on our database, but you can use any sort of database. I mean, you can link it directly into ArcMap because of plugins that have been developed. So if you have Resi files, basically the shape files that you get from ArcGIS, you don't have to do the sort of painstaking labor we're doing. It exports directly, and then you have a viewable web map that anyone with a browser can view instead of anyone with a $3,000 license. So it's a little complicated, the difference between vector or raster tiles, but it's pretty much just whether or not your image has an exact color for every pixel, or whether your image is based on math, formulas that relate lines, curves, things like that. So almost as though, do these tiles exist abstractly as coding, as this is the shape, or this is the curve of Norway's fjords, things like that. They aren't actual raster tiles. The way we did it is with images that I'm sure you all are familiar with, JPEGs, TIFF, PNG images, where every pixel has a color value. And that's a little bit more straightforward. The vector tiles are nice, but that just goes to show flexibility where you can choose whichever source you want. So for example, if you're bringing it over from ArcMap, the shape files would be raster, that's actual information. But if you're bringing it over from another software like GeoJSON, that would be JavaScript coding, which is a very common GIS standard. And that would all, I mean, there wouldn't be image files anywhere. You'd be able to export that and it would create the image files from your programming. So you do have options, and basically because of all these steps, you can choose what software you're going to use at every step, and you can customize it to fit like whatever job you need. The mapping library is Leaflet that we chose, but I mean, Open Layers works just as well. That's the sort of default program for GDAL tiles. So you can kind of mix and match and get the right library for your project, get the right plugins. I'm sure that this still seems incomprehensible, but basically you can choose whatever you want to make your raster tiles. You can choose whatever you want to get your feature layers. And if you have an expensive GIS software, you don't have to do that work. You don't have to sit there and pay someone to program or program it yourself. You just export it, and by the end here, you get this HTML file, which might seem like an end product, but really that's our goal, is for that to be a launching off point for you to be able to click on any of the images, any of the documents, and go to a larger site from there, and be able to actually interact with the material. So I think that ties into how Leaflet opens up to the other platforms.
Right. So as Casey said, in the end, you're given an HTML file. As I said before, Leaflet is built in JavaScript. When you download it, it's actually only 152 kilobytes. It's just a script file that you would copy the code into HTML and then generate your first map on OpenStreetMap, as we have here. But one of the interesting things about Leaflet is because it's structured in JavaScript and because it's not creating some end-use rendered product, it rather can just be placed in to your existing web framework because it's a front-end language. So that really gives you the ability to tie into anything. For us as historians, our usual suspects are, a Mecca or some type of content management system platform such as WordPress or Drupal. But there's other ways to tie in as well, specifically on the map. When you have a node or a point, you can click on that and get a pop-up, and you can put whatever content you want into there. You could have a page from your Mecca, like one of your items being fed out from a Mecca. You could have a feed out from any sort of file, images, text, links, anything that's going to help augment your spatial visualization or give context on that node. Because at the end of the day, Leaflet is mapping nodes, and for us to create our narrative and our context, we're having to draw in these external sources. And yeah, so do we want to go to the demonstration now?
Yeah.
And you can also go in between the map and sources, which there are some websites that have done that.
Let me pull up that prototype. So this is our map. Let me actually show you the prototype that we've put together, and it's just pretty much an example of, if you remember Dr. Beiler talking about those networks that she was hoping to visualize, communications along the Rhineland, Mennonites from Switzerland. So here's how it starts off, and you can see basically these are just little geodesic lines colored to represent which group is sending the transmission. So you have Mennonites from Bern communicating with Germans and Baptists in the Rhineland, and I believe the blue are those Pietist networks?
Yes.
Okay, so you have the Pietist networks from East Germany that then all of them tie in pretty much to the Quakers in London, which are then going to, it's going to move the map around for me a little bit here, which are then going to come to the New World. So I know this is just one little example. I mean, this is pretty much three networks really going over to the New World. But the idea is that that incomprehensible jargon of just bubbles from earlier will eventually be completely transcribed to Leaflet, have all of those points that might look clustered from far out. But again, you can zoom in and look at each item on its own. And that's what we were talking about with the multiple historical maps, but I think this is what Evan was getting at with pop-ups. Sorry. So that's just a name.
That's one that doesn't have something.
Yeah, some of them don't have anything, but you can get the actual documents tied to each node. And that's not a huge deal when you're just looking at one document or something like that, when you can just view an image of a letter. I'm sorry, let me just tell it to stop moving for me.
Did you write a timeline in JavaScript?
Yeah, I did. But all of these images, all of these source documents can basically tie into a whole separate web page. They could have a paragraph detailing you, not only giving you the transcription, but providing context for it and allowing a student to get all of that information from what before was just a network of white lines. Also, my lines disappeared, but they're there. So the way that Leaflet hooks into another front-end website is through these nodes. Each one is done with CSS styling, which is how normal websites are put together. And each one can link to a whole separate web page with a wealth of information and with all kinds of other functionality. Send me back there. Thank you. But yeah, our project goal is basically to take that photo of all the networks and get it up into this historical map with a longitude and latitude in every document.
On the nodes, on that last example you showed, where you click it and a letter pops up, can you have multiple letters, or do you have to use just one tile to drive you to a website or something?
You can have as many images, as much content, like you're saying, anything that can be in an iframe. Anything that can be on a website can realistically fit into that box, but I mean...
But you only get the one box?
It's scalable.
You can make the boxes big or as small as you want, and you can also change, like in our example, the like point where it draws to the actual place markers in the center. If you fed it out from the left or the right side, you could just make the box that much more bigger. If it's an iframe, you can have a scroll bar in it. So really, it's up to the CSS or cascading style sheet, which is how like we structure things on the web to determine like how it specifically appears within the box.
I've seen some really nice university maps that have that on the side.
My other question, ignorance again, raster is a word I've never heard. What if raster tiles,
Yeah.
is it a person?
Yeah. No.
So the files that we normally work with, the image files we normally use, I would say as historians, but just as laymen, people who aren't really into programming or anything like that, they're just going to be JPEGs, they're going to be TIFF files, they're going to be, if you open up Paint and zoom in and it starts to get pixelated, that's because the way that image is stored is, 1024 by 1024 squares, and every square has a color.
Right.
It's pixelated. When you're dealing with a vector image, if it's, say, a logo, it would use math, coding, programming to represent that image, and then when it loads, it's just going to interpret that and basically draw it for you.
At that size.
It's the word raster I'd never heard. I don't know what that refers to.
It refers to the pixelated structure.
It's a raster map, like, raster coordinates, so it's referring to each individual pixel, and it's saying this pixel's, 50% blue.
Right, I get the color, I just never heard the term.
Yeah.
And it does sort of limit the accuracy, because the lowest we can get down to is every pixel is a longitude and latitude, but that's kind of fixed by the multiple zoom layers. Any other questions? Do any of you think that you'd be able to implement this on your own if, say, you had a map already completely done for you in ArcGIS and just wanted to put it on the website, on the internet? So what we had to do was a lot of programming, but if you have a GIS application, if you have anything remotely mainstream, there's been a plugin developed to where with zero programming knowledge, with very little interface, with not having to open up a terminal, you can put that onto Leaflet and let anyone with a web browser view it. So I think the key aspects are the modularity, the fact that lots of institutions have plugins for it, and the accessibility. Anyone, anywhere can see it.
You're working with historical maps and those overlay on the street map program?
So,
Sort of.
sort of.
Not really.
So what we're dealing with in historical maps is the way they're projected. You know, Earth isn't flat unless you're a flat earther, which, you know, you do you. But the problem is that these maps, you know, when there's a dragon in the middle of the Atlantic Ocean and, you know, like you're looking at the east coast of North America in the 17th century, it's not accurate cartography. And so what we found very early on is that it's rather annoying to map it. And when you're looking at, for what we're doing, because our sources don't really get down to the street level so much as city, I think in the end we're going to remove the OpenStreetMap framework on the back of it, because a GIS projection for the level of detail we're working with what information we can derive from the historical sources based off of location, there's really no need for it. But if you had a more contemporary drawn map, or like a war map, or like, you know, like even Sanborn fire insurance maps, like those would very easily lay over to a contemporary, you know, OpenStreetMap with just a few projections or fixes on the projection.
And they do have fixes. You can go through and geo-rectify the map. That's not something you'd be able to, you know, just do overnight. But if you find someone with some free time, they can sit there and make that map, our distorted dragon in the middle map, match perfectly the contours of OpenStreetMaps.
Right, my website had something Google Earth used to have, and it doesn't work anymore. And it's maps from early 20th century through like the 1970s. So there's a wide variation in whether they're really accurate or not. But this is really interesting. I've got some ideas now.
There are some softwares where you can take, you know, a dozen maps and geo-rectify them together so that they're all the same amount of RAW.
Mm-hmm.
They're all equally projected.
Yeah, that's kind of what we were doing before, so, yeah.
I tried that. It was frustrating.
Yeah.
Yeah, we got to figure out every map we want first. Otherwise, I was like, oh, well, I have to do it again.
And with Leaflet, unlike Google Maps, because I know you were talking about Google Maps plugin, and I believe Dr. Giroux ran into the same problem with her dissertation, where she did this wonderful project, and then all of a sudden Google stopped supporting that plugin. This isn't going to happen with Leaflet. You have the code, and if you're creating your own map tiles from the historical map, that's all you. Like you can, it's not going to go anywhere. You have ownership of all of the code that is needed. Nothing's being loaded externally besides the OpenStreetMap map. So like you're buying some insurance from, you know, the whim and will of whatever Fortune 500 company you've decided to employ to map stuff out for you.
Maybe a slightly less technical question, but I'm kind of interested in, so Dr. Beiler said that she had this idea and then this tool presented itself, and the plugins, you can kind of start to realize the project that you wanted to make. Are there other ways, like surprising ways in which the sort of affordances of the tool like shaped your research and like helped the project take maybe a different form? Or alternatively, are there any things you wish it could do that it's not doing for you?
Well, I can answer the first question. I'll let them answer the second question.
Okay.
Not really, because I've been working on the project for 20 years. So I had this very, you know, I started with Dr. Giroux. Basically, she was the one who helped me extract some of my data, which I had started collecting back when I was still using a DOS-based database. And I could no longer use it, and I was despairing, and I met her at that camp, and we were having drinks and talking about our research, and I said, I can't, you know, I don't know what I'm going to do. I really need to find a way to map these networks because it's not working to map them on a page, but they're in this DOS-based database and I can't access it anymore. And it's like, oh, I'll help you with that. So when we first started working on it, I really was interested in understanding the structure of the networks and showing how that changed over time. So I started working with Gephi. And then I started talking to her about my, pie in the sky dream for a project. So, it was Gephi of its illustrations for a book, but when it was turning into a project, I just said to her, I want to be able to show all of the senders and receivers on a map, and I want to be able to show the lines between them, and I want to show how they changed over time, but I want to be able to click on the line that represents a letter and go to the letter, and go to more information. And so I think actually it was the student team who came up, I'm trying to remember who first came up with Leaflet, but we, there's a little group of research assistants who help out and we meet once a week, and I was like, okay, go find visualizations. And somebody, I don't remember who anymore.
I did the white sheet. I can't remember if it was me or
it might have been Karis or it might have been Casey, the other Casey. Somebody found it and said, look at the slave revolt page. Isn't that cool? Isn't that what you want to do? And I'm like, yes, I want to do that. And so we started looking at, what it was built on. So that's how we got to this.
Right.
And things it can't do that we wanted to do.
Can't do?
So,
Any deficiencies, yeah.
So I think that there are no deficiencies in terms of what it can do, but only in terms of how practical it is to implement that and who you have on your research team. I mean, some of the plugins get more and more complicated. One of the ones we're using is taking our raster coordinates, our pixels, and just using pretty simple math to make a projection out of that and convert all of our pixels to latitude and longitude. Realistically, if that plugin hadn't been developed, I could sit there in JavaScript and make that happen myself, but that's a constraint, that's a time constraint, and that's really an expertise constraint. But if you have someone who's a web developer or anything of that sort that's familiar with JavaScript, I really think the sky's your limit. You can even use Python to write your own plugin if you want. So if you can imagine it, Leaflet can actualize it because it's not a constrained system.
And getting back to things that we kind of realized that could be done, since we're looking at cities, one of the things the timeline tool I realized might be able to let us do is show what documents as a cohort by year to give context on the actors, I suppose interpellatively, as they're kind of coming and going out and where they were within their, and it would be hard to give that context using any other tool, especially the other mapping software, because it's going to be something where you're tweening through the timeline and these documents are appearing on a side window with the names of the individuals that are corresponding to and from.
How are you thinking about other scholars and researchers contributing material to it?
So that I haven't completely figured out yet, except that the letters that we have are housed in different archives in different
That was
places.
actually a question I was going to ask. So
And in fact, the letters are housed in, and they're in German, English, and Dutch. So our goal is to have them all either in a database or a database that points to them in a database in the libraries and the archives where they're housed, and then have partners in other countries who have the linguistic abilities to do the transcribing, right? And so the ways in which other scholars can play is to, so we're already talking to other libraries and archives that house the letters. So the first set of letters that we're working with are the Pemberton papers, which are now housed in STARS. But which we had a small grant, a fellowship to, they're at the Historical Society of Pennsylvania, and we had a fellowship to digitize them, and the fellowship was meant to go to an archives where there's a repository of documents that a scholar needs to work on and digitize them to make them accessible. So that's the sort of prototype that's the set of letters we're using to prototype it. Ultimately, I hope that we can find some other scholars who are either interested in contributing more of these letters, who are interested in transcribing or doing research based on these letters, My next sort of level of pie in the sky dream would be to find other scholars who are interested in looking at minorities and refugees and migration and immigration, and link this project up to other migration stories in other places and other times. Because what always is so compelling to me is when I read what's happening in these letters, nothing has changed in our world, right? So people are still being discriminated against, persecuted, othered, in very similar kinds of ways. Different groups for different reasons, different places. But I think it would be really fun someday to be able to create a project that would allow 21st century immigrants and their letters and correspondence and networks to be sort of put in comparison with what's going on in the 17th and 18th century. That's way down the road. I don't know how I do that yet. So I don't know, did I answer your question? Good. Good. But yeah, I think the first step is just trying to figure out how to get all of the archives on board. So I have 5 sort of major archives at this point. The Mennonite letters are in the Amsterdam Municipal Archives. The Quaker letters are at the Society of Friends Library in London and at the Historical Society of Pennsylvania. And the Pietist letters are in Halle at the Frankische Stiftung and at the Berlin, the State Archives in Berlin. So I need to get all of those players on board first. We'll see how that goes. Halle is on board. Historical Society of Pennsylvania is on board. The Amsterdam Archives, when I talked to them this summer, they basically said, oh, well, you know, you just click on the inventory and we'll digitize it and you can do whatever you want to with it. Okay. It's, you know, 1,000 letters. So they sound sort of on board. I need to go back and really make sure that they're really on board with it. But what I expected to be a long conversation was a 5-minute conversation. And so I was like, but they haven't yet prepped the finding aid for it. So there's a little work there too, yeah. The Friends Library, however, the last time I visited in 2014, they were still using their 19th century card catalog. So I think that's probably a different story. Pardon me?
That's
Yes.
the one in London?
The one in London. So I'm hopeful, but I haven't been able to find any digitization projects yet on their website. So I need to go actually pay them a visit in person.
It's a tough job, some of these guys do.
Yes, exactly. Exactly. So that is going to be the challenging one. So there we go. That's the project.
Well, thank you all so much.